Yeah, I can hear you well.
Perfect. Super excited to be here. This is one topic that I deal almost on a regular basis. So I thought, why not kind of share some of the learnings that I have and also kind of bring in some of the technical work that has been going on, especially in the open source community. So I thought, I initially thought like, hey, machine learning in production sounds good. But then, people will be excited. I thought maybe I should change that title to high performance model inference. Uh, so and the reason for doing some of these things is twofold. One is there are probably hundreds of articles out there on Medium where people just say that, oh, let's open up a Flask application and do an API, right? Again, it's not a wrong way of doing it, but there are a lot of problems, especially when you're managing a production system. It is you're not taking advantage of the fact that, hey, there are some open source tools that are available that can also help you speed up inference. And purely so is because model scoring is a very costly affair. And if you do it poorly, you can land up with a lot of issues, both in terms of cost and overheads to maintain that. So doing it right, doing it a correct way is very, very important. So that's why this topic. So who am I? So let me start off with a base introduction. So my name is Setu. I am currently the director at Property Guru. So that's my day job. In the night, like I do this evening, oftentimes I do have a YouTube channel as well. You can find me on YouTube with my full name. I'm also the Microsoft AI MVP. This is my third year going. And I'm also an avid Kaggler. Between the first two jobs, I barely get time to do Kaggle, but a couple of years when I was doing it, I probably used to regularly make it between the top 100, top 200 of any competition. So I think probably with more practice, I could have done better, but I think I'm happy where I am. So I have given some of my links both for Twitter and LinkedIn. Feel free to connect with me over there. Okay, so now that's enough of the intro. Jump in, right? I will kind of request one thing is, I don't have a slide towards the end which says questions. So if you have a doubt, if you have any questions, feel free to, ask it right away, because I'm not going to wait till the end to kind of do that. All right. So having said that, let's kick it off. So in my previous role, I used to work with a company called Nielsen. They were into market research, market survey, and those kind of activities. One of the things that we had to do was use machine learning to kind of categorize and figure out the attributes. So typically, we will get a lot of data from e-commerce companies, which just has a product description, and then from that product description, we had to infer as many attributes of a product as we could. We also had to kind of Nielsen had a product hierarchy, so we also had to do a classification for that hierarchy itself. So let's take an example of Coca-Cola. So Coca-Cola is of course a beverage, but remember it's a non-alcoholic beverage. So the hierarchy always went like this: beverage, non-alcoholic beverage, cola category, and then you kind of come off to there. So these were some of the hierarchies that we had to kind of come up with. And if you have done any sort of machine learning, the first thing that comes to your mind is I'll have to do some sort of classification, right? Map your product descriptions into a category or a hierarchy or an attribute out of that, or extract the product attributes from a given descriptions directly over there. So at that time, we were working with a lot of natural language model, which is what we had to do. And it could get very complicated very, very fast. Some categories like drinks, non-alcoholic beverages, they were relatively simple. But if you get into beauty, face masks, chocolates, the hierarchy could get very, very complicated. The number of attributes that you could have gets very complicated. And then again, you have a lot of local products. Global brands are easy, but again, then you have a lot of local products or local competitors or local players, and that makes your job harder. So we had to kind of come up with some of these things as well. So eventually we ended up using a lot of gradient tree based approaches. And in that time, the only way we could put some of these things into production was a PMML based approach. I'll kind of explain later on what it's there. And then what it allowed us to do is, initially when we started off with is we had one model per attribute. Later on, we did like a deep learning keras based model, which kind of simplified our life. But initially we had a tree based model where we had to, one attribute, one model, and kind of build that up. So for a category, I could end up having, 300, 400, 500 models, which had to be updated on a regular basis. So if I look at a country itself, I would be managing 500 or sorry, 5,000 or 6,000 models to do that. And PMML kind of saved our life rather than going in a typical pickle way. PMML and the open scoring approach kind of helped us, make our life much easier. And since then, I've kind of continues to explore different objectives, different ways of putting things into production. The next one that we ended up doing was around Property Guru. That's my current role itself. So until recently, we had a lot of the agents when they kind of do what they will do is they will have a photo. And as you can see in this picture on the right hand side is that you have an agent photo. There are a lot of non-value added features on the photo itself, which completely blocks the picture that you want, that you as a consumer are interested in. Agent is kind of trying to make a sale. They will have a lot of call to action. They will say, call me now, guaranteed sale or discounts or whatever. And it formed for a very purpose. We kind of encourage the agent not to do that, encourage them to kind of think about the user experience. But that was not going out well. So we said, all right, last April we said, all right, any of these photos which is not a property image, which doesn't describe a property, we are going to reject it. So if you have a phone number in there, if you have text in there, you have an agent photo in there, all of these are going to be rejected. So we started again, this is again a very simple image classification. So what we had to do was deploy these models again into production. And we had to do it at a scale, right? Because you will suddenly see a lot of peak that will come in. And then, it will kind of die down again till evening, and then it picks up again and starts all over again. Now, we had to kind of scale up and down very, very fast. So there were a couple of approaches in there. We could have done TensorFlow serving and gone down that approach, done some kind of batch processing. But in either case, right, Kubernetes was not a solution that we could work with. So we had to kind of scale up and scale down as well. And we went down with a serverless deployment that allowed us to scale as quickly as possible to as large volume as possible as well. And that's something that we use even till now. And if you know any of the cloud-based server deployments, there are a lot of limitations in how much CPU you can use, how much RAM you can use. Of course, you don't have access to any GPU, so that rules out any of the models that you could think from a classification perspective. So we had to kind of understand the basics and make sure that our models are able to kind of run in a much more effective way. So we started doing that. That worked out fairly well. There are a lot of sub models that work out in there, but that does the job fairly well. The next one, yes.
I'm sorry to disrupt you that. So you mentioned that you would like the question to be answered like in real time. So I have two questions here, but I can summarize them in a bit. People are asking, why can't we just expose the endpoint as API through fast for production?
Okay, so actually, let me do this. I had a slide. I thought this question won't come up. Let me just put
Yeah.
that slide up. Uh,
All right.
so I kind of hidden this slide just for this, and this is, I took a screenshot from one of the existing code that was in there. So this is how typically you end up writing a Flask-based API, right? Again, nothing wrong with this, right? But what happens is you would want your app to have consistency in terms of APIs, right? Versioning to be there, right? You want payload consistency across all your API method, right? A lot of these times when we work with the engineering teams, we have a contract, which means that, they will send us a particular payload and we had to make sure that we honor that payload. And again, the response that we give up is consistent. Now, when you kind of do it in Flask, nothing of that is consistent, right? And it makes it a big challenge to kind of, uh, train new users who are coming in and saying that, oh, this is how I need to write it, this is how I need to maintain it. Serving, of course, solves a lot of these issues for you right off the bat. You can do versioning, you can do like your APIs are consistent, your payloads are consistent, your responses are consistent. So there are a lot of the cool things that you could do with those things. The other factor that really comes into play is the fact that Flask, again, when you kind of load it and work through that, there is uh, lead times associated with that. So especially when you're working with deep text-based models, they are kind of very difficult to manage it in Flask because if you have a model which is like 2-3 GBs, your Flask is not going to go a good job in there. When you want to kind of switch over in production, unless you kind of manage it effectively, that's not possible to do it either. Going down the serverless path allowed us to do that very, very effectively without having to worry about, hey, what's happening on the back end. Did that answer your question?
I think you did.
Okay. There's
Thank you so
another
much.
one which I see who's building the front end or an aspect of software, and all we are doing is building a model that spits out a prediction. Why not deploy that as an API and they can call when there is needed? No, so this is typically how you would do it, right? But what happens typically with the engineering team is they put uh, so for example, in Property Guru, right, our infrastructure team is completely different, our engineering team is different, and the data science team is again kind of doing the modeling aspect of it as well. So of course we would like to, which would mean that somebody from my team has to manage it. The other way is, hey, we work with the infrastructure team, align with the company best practices, and make sure that we are working towards a common pieces. So when we kind of work through that, there are very strong requirements, and I'll cover that in my presentation. But for the sake of answering the question, there are sort of key requirements purely from a latency perspective that you have to maintain, right? And I'll show you in the code itself, right, of how you can kind of still work through your regular process, still go through the your typical model building process, but just when you come to your production pieces, you can kind of compile your model or convert it into uh, uh, platform agnostic way, so that your deployments become much easier and you're not boggled down by versions or typical package issues that often come up with machine learning production deployments.
Yeah, thanks a lot, Silvio. Close the question. Thank you for answering.
All right. Did any other questions at the moment?
There are no additional questions in the Q&A.
All right, cool. So the other one that we did was what we called Property Guru Lens. This was super cool, right? It took us quite a while to kind of get this right. So the idea is that, when people are searching, and, this is based on a lot of real life pain that, a lot of us have gone through. When you're kind of going out property hunting, I don't know how, when you're going property hunting, you find a building that you saw, it looks super cool, but the only way where you could find out what the name of that building is you open up Google Maps, figure out where you are, zoom, figure out what building you're looking at, and that's how you kind of look at it. So we kind of wanted to kind of bring a different perspective into doing this search. And we said, all right, let's do it from a geolocation perspective where we could use augmented reality to kind of show the results right on the camera itself. So the idea is that on the Property Guru app, now this is only Singapore, so this is not going to work for Malaysia. But if you do come to Singapore, download the Property Guru app and play around with this. You have to sign in, but once you sign in, take your camera, point at the building, and it instantly tells you, what building you're looking at. And these green color icons that you see essentially become those dots. And if you click on it, it will tell you, how many buildings are available for rent or sale, depending on what your interests are. Now, of course, we had to kind of take into account geolocation. So that kind of posed its own challenges. And then, we had to kind of look at the camera feed and say, hey, are you pointing at a building or are you pointing at an obstruction? So that would kind of help us determine or do some corrections on the back end for the geolocation itself. Now, when we started off the models, our models were fairly heavy. Every minute, early stage models, they were draining the battery every minute, right? So 1% every minute, the battery was getting drained. Itself, right? So I had to keep holding my camera for about 15-20 seconds before I got my results. And if I moved my camera, whoop, it starts all over again. So it was very painful for us to kind of set this up. So our key task that we were challenged with is, one, the classification has to be super small and the latency had to be very fast without losing accuracy in there. And the other thing that we kind of challenged ourselves is all the calculation should happen on the device itself. Because every time we kind of send it out, it poses a lot of privacy concerns, because I don't know what are you pointing your camera at, right? Because you are pointing at a building, you could be looking in somebody's house, right? And I don't want to kind of be responsible for processing those images on my side and kind of get into legal issues as well. The other thing is, if you want this product to be successful, I could not send a geolocation in there, right? There is already a lot of these privacy concerns people have about going through sharing all this data. So we said everything needs to happen on the device itself. So finally we came up with a very small that is just about 4 MB in size, works right on the device with almost millisecond latency. So it works perfectly fine for us. The data never leaves your phone. You can actually try it out, put it in an airplane mode, it will still work and identify the building. You won't know how many properties are available for rent or sale, but it does the job. And that's what we kind of did with that. So kind of had a pretty broad experience with trying to tackle ML at scale in different edge cases itself, right? So had I been none of these models would have worked, or managing them would have been a super nightmare. So that's why interoperability is super important. And one of the questions that was asked earlier, so let me hit upon some of those things, right? uh, so three things that I always kind of bring into account. uh, your training environment and your inference environment are going to be completely different. Your training environment is typically resource rich, where you will have access to high performance compute, or you can, nobody's going to question you on the power consumption at all, right? While your inference, right, I shared the example with you that we were doing this on the edge itself, right on the device itself, which means that we had to compute all these calculations on the device, right? So sometimes when you're doing on the edge, you might not have enough power to do very complex calculation, right? So your approaches have to be very, very simple. There is a chance that in case of Lambda, or in case of any of the cloud functions, serverless functions, you're not going to have the liberty to install whatever packages that you want. And most of these packages come up with a lot of dependencies itself, right? So you are not going to be able to do that there. So keeping your inference environment as simple as possible is super, super important. The next one is inference requirements, and typically this comes in through engineering, because you don't want to kind of mess up the user experience. Your latency and throughput will often drive the infrastructure requirement. And if you look at, there's a paper from Amazon on SageMaker. They say that model scoring will be about 40-50% of your lifetime cost of that, even if you include the people into that total cost itself. When you deploy that model, the choice of libraries that you have used may not meet the performance requirements or the infrastructure requirements that you have, right? Or you might have to do a very complex engineering to kind of support that. So that could be one of the potential issues. And again, everybody who's worked with data science team, they have their specific way of looking at it. In Property Guru, we use Python. Some of them use R. Engineering prefers a different stack itself, right? So either I could spend time and effort in maintaining that infrastructure by myself, or I align with my infrastructure team and work with them and kind of do it. So that interoperability is super important, and just working through Pickle or just working through Flask may not be the right approach of tackling those perspective. And in this session, what I want to do is reduce that latency using the various toolkits that are available right now. All right, so let's look at some of the common approaches. Again, this is not a comprehensive look. This is something that is commonly used across the board. Now, again, I've covered majority of the scenarios, but I'm sure there are quite a few more, deep learning for J, which I have not covered here. But let me start with what we have. Scikit-learn, their typical recommended method is Pickle, right? You can convert some of these models into core ML. You have a scikit-learn porter that allows you to convert the code into Java. There's a sklearn compile trees, which is also pretty good, but it's not been used extensively with sklearn to PMML format, something that I shared with you earlier, how we used to use that back in Nielsen. Of course, you can convert this into Onyx format as well, and something that we'll take a look at it. Now, all the three gradient boosted trees, you have cat boost, you have light GBM, you have XGBoost. All of them have a way to save the model in an internal format or convert it into some format of C++. And they are very performant in themselves itself, right? Most of these libraries are written in code like C++. So taking that model and working that out is not too complex. XGB can also be converted to Core ML using the default Core ML tools, while Cat Boost can directly save into Core ML format. Now, PMML is supported both for LGB, Light GBM, and XGBoost as well. Again, there are very specific libraries in there, but something that you can quickly, get it up and running. So Core ML across the board, it's the default toolkit supports a lot of libraries, and getting your model into iOS is super easy. Anybody can do it. Now let's look at R. R has, again, very similar to what you saw in Pickle. It has its own save and load modules. Besides, some of the libraries offer their own approaches of doing that. And again, if you want to deploy, you can use rserve, and you can write a very simple Java script, and it will work very, very well, right? People have used this in production too. But that's not something that I've worked extensively with, just something that I've known and played around with that. The next one, again, when you look at deep learning, again, fantastic support across the board. You cannot go wrong with any one of them, right? TensorFlow, again, has a saved model, which uses Google's approach. TensorFlow serving is used for TensorFlow model, but again, XGBoost is another library that you can use with TensorFlow serving. It also supports Onyx. So anything that can be converted into Onyx can be served using TensorFlow. And TensorFlow serving is, I think, one of the best things that has come out of TensorFlow itself. If you want to take your TensorFlow models into iOS, Core ML tools allow you to do that. Again, all the libraries allow you to kind of convert your deep learning model into something that you can use in iOS. WinML tools, again, which comes in from Microsoft, allows you to kind of convert any of the deep learning models into into Onyx format, and you can take that Onyx format and kind of be platform agnostic, put in on a Kubernetes service or any of the cloud functions, and it just works. Deep learning is kind of fairly easy to kind of manage it. Uh, and for deep learning, again, there are a lot of compilers that are there, which can kind of take your deep learning model and improve the performance by compiling it using Apache or one of the most used libraries out there, almost as much as 5x when you even combine PyTorch and TensorFlow, right? So even in my day-to-day experience, right, we use a lot of tabular data, and working through tree-based model is a more common thing than people think otherwise, right? So when you're working with tree-based models, getting a tree on a highly performant system is super essential. Or working through what we call as traditional machine learning approaches is again super important. There are open source libraries out there. Nvidia has this library. They have recently come up with this called Forest Inference Library, FIL, which is part of their bigger ecosystem, and that is dedicated for all these tree-based inferencing problems itself, right? So they are very focused on that. Again, when you want to do this, you can either do it on CPU or GPU itself, but again, their inferences are very fast. And again, some of these comes in through the fact that they are very dependent, right? Especially when you're working with these boosted trees. Your second tree is dependent on first tree, your third tree is dependent on the previous two, so on and so forth. But during inference, all of them can practically work in parallel. So that kind of gives you a lot of these boosts, and kind of go from there. Recently, Microsoft, not recently, this was a paper that came out last year, Hummingbird, which is from Microsoft, uh, which said that, I'm going to kind of compile this into tensor operations, which can do the job much faster. So they do this for quite a lot of the existing models from scikit-learn that you can convert it, including some of the feature engineering itself, and you can compile it into a tensor operation that gives you a very high speed boost. So something that you could work with. Treelight is from the same company that got you XGBoost. So they have kind of done their own library. And if you know about Amazon Neo, which is again kind of a compiler. So Treelight is kind of an underlying library for Amazon. If you have worked with XGBoost or LightGBM, you can use Treelight to compile it as a DLL. If you're working on Windows, and that DLL is something that you can put it into production without requiring any of the underlying infrastructure in there. So your task becomes much faster and much more efficient in there. Any
Hi, Situ.
questions? Yeah,
Yeah,
perfect.
Situ. There are a couple of questions there. Would you like to take a look?
Yeah, sure. Okay, so the first one is how do you ensure that the scripts that are used in model development are reusable for production? You mentioned aligning with your infra team, but does this come at a cost of data? No, it doesn't. Once you kind of compile this and make your approaches kind of uh, I would say, standardize your approaches into production. Like, let's say, you go with an Onyx approach or you go with a compiled library approach. Then, your typical, pipeline building approaches can take over. And then the infra team can take the input coming in from the data team and build a model out there that could be usable for serving the APIs or serving it in a way that's, again, kind of platform agnostic or library agnostic. So having that standard approach is super important. If you go down the pickle path, the challenges come in is, you will face version control. It doesn't maintain the state. There is no reference to those classes, and those classes needs to be there. So once you kind of do these sort of conversions, either with Rapids or Hummingbird or Treelight, you kind of remove all that dependencies out of there. And then, you could have a standard approaches for either, you could still end up doing Flask, right? But then you can maintain different versions without messing up the contracts that you have with your engineering team itself. Do you optimize the code by recompiling in C++? You could do that. Example, I have code as well. So I'll kind of take you through an example and show you the performance improvement at each step. So you can see it for yourself. How does that work? How can you persist the model and still be able to load it and work it out as well? So that works out fairly well. And once you have this standard approach of, how do you want to do model persistence, then you can create your, let's say a Jenkins workflow for your pipelines and deployments, where it can go to the staging integration before it goes into production. You could set up those pipelines and have it up and running, right? So that's one way where you could work that out. uh, After deployment, your model, how do you keep improving while avoiding catastrophic forgetting for each new version? Now, okay, so there are two different parts into this, right? Once the model goes into production, right, you still have your base model, right? So you could still work with your different approaches. So both in XGBoost and LightGBM, improvement process, where you could say that, okay, let me take the best iteration in there, uh, dump that model and put it into production, right? And I could have a continuous integration process that could be sitting there. But that discipline of model versioning is, again, kind of probably a topic in itself. But once you have a way of, how you are kind of doing model version control, then setting up those pipelines, the DevOps team can just take that approach and set that up as well. So don't just work with your pickle approaches. There are a lot of different ways to kind of suit your edge case needs, and don't get bogged down by the fact that, hey, I need to stick with pickle, or I need to stick with some of the default libraries that are out there that I need to work with. So do you have staging environment for data science? Yes, we do. For example, Lens. For Lens, we we now have a staging environment where any model kind of has a proper test case that goes through, and there's a proper testing that happens on that before it even goes into production, right? And this is similar to any app that you would end up developing on there. So yeah, we do have a staging and a testing environment as well. Given the number of models you operate and their complexity, how do you manage the number of features required? Now, this is, I think, probably coming back to the second part of the question again. This has got to do with, how you do your feature engineering, right? There is never a pause that comes in where you say that, oh, my model is perfect, there's no other improvement that you can do, right? There is always data augmentation, new data that comes along that can either improve or decrease your model. But what we do end up doing is set up baselines for that, set up test cases for that, make sure that the model is kind of going through and working the way it should. We have our own explainability approaches to make sure that the model has not learned something crazy before it goes out into production. There is still some amount of human touch. It's not completely automated before we do it. But for some of the standard approaches that we do, Treelight and Hummingbird are something on our radar that we are experimenting at the moment.
Hi, Situ.
Yeah.
Thank you for answering the 5 questions just now. Would you like to take a break before you demonstrate your workflow?
I don't know. I'm good to go. What do you guys want to do?
Yeah, we just worry about you because you've been speaking for quite some time now.
Yeah, don't worry
Would you
about
like to
that.
take about it? All right, got it.
Don't
Yeah,
worry.
please go ahead. Thank you so much.
So just one question from the audience itself. I don't know how you want to do it, but are you guys comfortable with Python, right? So if I go through the Python code, will you guys understand it, or do you want me to explain a little bit more when I go through the code? Just a question out there.
So maybe I rephrase a bit. So all the attendees. All right, Nicholas says it's fine. Eric says Python is okay.
Okay. So there's one more question that's come up. How do you monitor your models? Do you adopt a champion challenger approach? Um, yes, in an offline sense, yes, we do it. So we have our baseline metrics that we would look out for and make sure that the model is not actually degrading or it takes into account some better features. Then certainly we put things into production, even sometimes at a cost of a slightly hit in the accuracy itself, right? Um, but if we do feel that the model is going to provide us more stable outputs, then a slight drop in accuracy is completely acceptable at the one. Yes, we do monitor our models. One of the things that we also look at it is data drift. So we do monitor the models, your typical monitoring, what is the inference speed and stuff, but we also kind of keep a track of one, what is the model trained on, and what my input data is coming in, so that if there is a gap between the two, then we know that, hey, there's a drift that's happening in the data which my model is not trained for, and something that would require me to deploy a new model based on the the recent data sets that we have seen. So that kind of takes that up as well. All right,
I
so
see.
let me,
So
yeah.
maybe there's a concern from one of our attendees. So maybe give it a brief explain.
Sure. Let me start off with zooming in a bit. I don't know if this works out. I hope you guys can see it. Is this legible enough for all of you?
I'm okay. How about the rest? Eric say okay.
All right, perfect. So let's that start, right? So I'm going to not look at rapids now. Again, I do have GPUs. I'm doing this as a Kaggle sheet. I wanted to use a Kaggle data set, but we are almost short of time, but let's work through that. So I'm going to focus only on Hummingbird and Treelight. These are super cool libraries that you should know and work with. So the first thing that we are going to do is do an installation, right? So I'm going to do Hummingbird, and I go with Onyx as well. So I can convert it into Onyx, and I have Treelight, and Treelight has two ones. This is your typical Treelight for converting the model, for persisting it, and then you have a Treelight runtime, which is only for runtime itself, right? So these are two separate libraries that you have to do. Now I'm not going to run through the code, but if you are interested, I can run through this. So let's set this up, and once this setup is done, I've done the basic installation in there. I start off with my basic imports. When I work with Hummingbird, like I said, right, it converts it into a tensor operation, and they use PyTorch as one of their underlying libraries. So I need, again, it's like the bread and butter of data science. Then I need my typical XGBoost and Light GBM. I have those. I do my imports for Treelight and Treelight runtime. I need my Onyx. Onyx also has my runtime. So once you have your Onyx model, all you need is runtime. You don't need the other two. Other two are mainly for converting your data and your model itself. Next, I have Hummingbird as well. Hummingbird doesn't have a runtime yet, but at least you. Last one which I have is time it, so that I can show you, how long does the model take to run, and we'll run it multiple times so that we can average it across the board. All right. So, I'm working with a very dummy data set just to kind of drive home the point. So two things that you have to kind of take into mind, right? I'm kind of working with NumPy library, and in your real life, you are going to have more like Pandas library. So something that you have to keep in mind as you go along, right? So that's a disclaimer that I will put in. So if you go home and later try and say, hey, pandas, and try to convert it, doesn't work. It's probably because you'll have to convert your pandas data frame into NumPy, right? Some of the models do work with pandas data frame, but NumPy is your task to go. So what I've done is I've generated a random array of I'm not going to really worry about the accuracy of it as well. I generate random classes. I generate 10,000 by 28, so each has 28 features, and then I try to see what those things are. Of course, I could have done generate data sets itself, which is also a library in Scikit, but that's not the objective in here. The objective is how fast can we do the inference. So I have this typical speed function where I am going to run each one of them 5 times and repeat it 2 times. So overall, each code will run 10 times in total. And then I will, for each one of them, I'm going to pick out, what is the average, what is the min, and what is the mean. So I'll start off with a simple light GBM classifier. So I have a model. I, you know, I leave all the default adders. So light GBM has 100 trees. I'm just going to leave it as is and build my model, right? So my model has been fitted, which means that, I would do a lot of steps in real life, kind of address some of the missing values, deal with categorical values. And, I'll tell you why that is important in a moment. Then once this is done, your model is ready, you have tried it, it's ready to kind of get converted into the models, right? So first we'll do the Onyx model itself. So I'm going to give my input, which is what I want to define. And it also needs the shape of what the input is going to come in as. And right now I've kind of done it 10,000 by 28. But depending on how you guys are going to deploy this, your shape might be different, right? And that's something that you will have to kind of work through this. So this is something that the Onyx model needs, and I'll show you how it uses it. Um, then I convert it into a light GBM model where I give it a model, I pass it the initial types, and then I target which version of Onyx that I am looking at, right? So that's all this model is doing, right? So once my model is there, it will generate this nice tree that you can evaluate, and you can of course investigate an Onyx model. I'm using something called Netron, which allows you to kind of uh, inspect your Onyx model itself. So I have my input. So as you can see, I can't zoom in further on this. Uh, Hopefully you guys can see it. Uh, Let me see if I can do it even further. All right. So your input, which I defined, it's going to be 10,000 by 28. And my output is a label, which is just an integer, right? This is my tree that is built. And this is basically how the tree has been represented internally, right? You have my class weights. I have all my trees IDs done. I have my node IDs identified. So everything that I need for the tree is available here, right? So basically, if you know about a decision tree, it's nothing but a big bunch of if then else. So that's kind of encoded into this Onyx model that I can then deploy it. And that's why some of these tree libraries are super cool because one, you can translate it into any language and they become super easy. And saving the Onyx model is super easy, right? You can just serialize to string and just dump it, right? So nothing fancy that's sitting in there. So I'll convert this into an Onyx model using Hummingbird itself, and let's see how fast the model takes. Now I do a typical Onyx model. Took me about there's 10 iterations. Took me about 1.7 seconds, which is again not bad, but I'm sure we could do uh, something better. Now let's move on to the next one, right? So like I mentioned, Onyx, Onyx has an inference session. So of course, when I do this, it's not sitting in any inference session itself. It sits as an inference session. So this is what I do. I make sure that my input and labels are correctly done. So that's what I kind of get out from the sessions. And then I run my speed test, right? So I look at my default model, which was my light GBM model. And for doing that inference, which was 10,000 by 28, uh, it took about 0.5 seconds, right? So again, much better than what you had before. Now let's continue on and convert it into an Onyx model and see what do we get, right? And there are, again, a lot of different algorithms in there. So what the first basic algorithm that's there, which is not kind of tuned for trees or decision trees. These are good for any model, any machine learning model that you will come across. This is what it's going to do by default. So if you don't specify anything, it's going to do a generic matrix multiplication. I'm not going to go into the steps, but basically it does the mapping between input and output through a bunch of internal tensors and everything. Now, when I kind of do these runs, right, I could test it on a GPU or I could test it on a CPU itself, right? It's super easy to kind of do it. Just put the model into CUDA and do a predict X, right? Or if I don't do CUDA, which is essentially telling, hey, don't put it on a GPU, I can run it only on a CPU itself, right? So my GPU got me zero point 0.5 seconds. Again, still a good improvement from where I was before. But when I just do it with CPU, I've already got a 10x improvement. Instead of being 0.05, now I'm 0.005 seconds, right? So you have got a significant boost from just using your light GBM as a way to going all the way and using your Onyx model and using or Hummingbird model and just using CPU itself, right? So pretty good, I would say. Then they have another two algorithms which are kind of work with trees. Again, there is a lot of redundancies in how the previous model worked out. Now, when you're working with tree, you don't have to evaluate the whole tree, but only specific tries, and this is what a tree traversal does. So in my extra config, I just set up tree traversal and again do the same, right? Now, again, you're not going to see much difference between your gem model versus your tree traversal. Uh, Most of them, for all practical purposes, give you something similar. But let's look at what happened to your GPU. Your GPU went in from 0.5 second. Again, you got a massive improvement in your GPU inference time as well, right? So, of course, going through a tree traversal on a GPU, despite the fact that it had a huge overload of passing the data back and forth, you still got a very good inference time itself, right? So again, pretty decent to work with. There's another algorithm which says, I'm going to convert this into a perfect tree. Now, again, you're not going to see a lot of difference in there, but this is a very, very good way to kind of work with decision trees, right? And you can drop your inference times even further. Again, there is a very minor improvement, just about 10 to 16%, depending on how you run, how many times you run it. But you do get a marked improvement by converting into a perfect tree where it says that, okay, now all my trees are balanced trees and work that out. So pretty good way of going from, working out to a second to almost millisecond in prediction. And remember, my X is still 10,000 by 28. So you went in from almost a second, half a second to, getting milliseconds for your inference times. And this is working on a CPU machine. Any questions on this so far? There's one on Q&A. Let me see. In your experience, how many years of working experience? Um, yeah, I have a very controversial view on this. If you guys are motivated, uh, you know, there are so many tutorials out there, both on Coursera, open source. Just get started, right? A lot of this in your real life, in your machine learning world, it's all about, can you solve a problem? Can you solve an issue at hand, right? Frankly, my boss will never come and ask me, hey, Did you use CUDA, or did you use you have to take a problem, convert it, take that business problem, convert it into something that you can apply, and then make it work for you. And if you keep on learning and practicing some of these things, you will get better at it. I can show you my Kaggle. I'm on Kaggle. Probably towards the end I'll show you my rankings, right? And I'm not ashamed of it. 3 years back, I never used to even come in top 1,000. Now on any given day, it's very easy for me to come in top 100, 200, right? Out better, right? So it's all about your motivation, to kind of learn these things and start applying it in there, right? If you are short of problems, Kaggle has a ton of problems, right? Start to practice. Don't worry about who's watching or what rank you got. Just start, right? Whether you want to pick R, whether you want to pick Python, you want to do TensorFlow, PyTorch, doesn't matter. Pick something, start, and start to learn whatever you can, right? That would be my thing, right? Start to work for problems. You will start to see patterns that will come out of it. You will form your own experience in there, and get going, right? And there are companies that will give you a chance based on that. And if you target something like a machine learning engineer, which is a balance of your engineering programming skills versus your data science skills, you are in the right spot itself, right? You don't need anything more. I hope I answered your question.
That's very, very motivating.
Yeah, don't worry about what others are thinking. What everybody sucks when they start. uh, I'm sure when you started programming, how good your models or how good your code were, and when you look back, you'll be like, who wrote this? So don't worry about all these things. All of this will come through practice. But just make a promise to yourself of learning new things. And I think there are a lot of free tutorials out there, and data science team has exploded purely because of the fact that people are learning new things. Cool. Any other questions? All right. So now, all right, then none. Okay, so now let's go to the tree light model. So Hummingbird library, go out and test it. The only way you can persist a Hummingbird library is through Pickle, but that's okay. Probably this library is still under works, but something that you could work out with. Now, tree light, I absolutely love this library. It's so sparse on documentation. It's crap. But Treelight is one of the foundations on which AWS Neo is built, NEO, right? Go and read it up, right? And Amazon promises 2x improvement in inference times for edge use cases. So this is one of the underlying models in there. They have some of their own. TVM is one of the other ones. But again, take a look at it. It's fantastic. So anyways, what we are going to do is I'm going to convert this model into my light GBM model. Remember, for doing that, I save it as a text file. And then all I do is load the model. Now there's a special, because this made by XGBoost, they have a very fancy way of loading XGBoost. But we'll go with a standard way. So I give the model persistence file, and I say the model format is like GBM. So the other format, because it's XGBoost, you can give XGBoost itself, and it will convert it into a tree model, tree light model itself. Now it needs a compiler. There's some documentation in there, but default GCC is there in most of the environment, so it's easy to do. And I create a shared library called LGBM. You can call it whatever you want, and it's going to kind of give your outputs to be very verbose, right? So I give my compiler, I give my path of which is my output file, and I export my library. So as you will see in the code below, it's going to kind of do a compilation in there. And once this library is generated, I am good to go, right? Which means that this library can work in any environment that you have. Now, all you have to do is load the library. I'm going to keep the verbose as true. Load your data. It needs a batch. It kind of works the same way, just how you saw in the previous one. You have to work in sessions, and then you do a batch prediction itself. Now, what you will see that, when you do it the first time, your performance is going to be very, very similar to what you have. But if you have your same data that you're loading in, which is not going to be the case, you will get inference time. I mean, this is not a right number, so don't go with this. This is because I was running it again. It gives you a deceptive answer, but your real life is going to be very much similar to what you are seeing here, right? So don't work with this. So just compiling this and getting into a library gives you an environment free where all you need is a tree light model and go and deploy it elsewhere. So that's all I had. I had another Boston data set, but I'm how easy it is to take your model, dump it, compile it into a library, and be ready and good to go into an environment that could fit into your any of your inference models. So I hope this was useful. Again, open to any questions that you guys might have at the moment.
Yeah, so I think let's give it a minute there. Yeah, I think so. Do you have a new question? Come in.
Hold on. Most of the data scientists admit said Kaggle is not useful, unrelated for your work. What is your opinion regarding this? Again, I probably have a very controversial opinion on this. So there are a couple of things in which I see Kaggle to be not useful, and I can see where they are coming from. So if you look at your Kaggle rankings, and since I'm on Kaggle, let me just show you some of these things, right? So so that's me on Kaggle. Used to do fairly well. So like I was saying, right, sometime back I used to be ranking such pathetically. Now let me open up this competition, right? This was something that this is probably one of my most memorable competition. Now let's go to the leaderboard, right? So my top score was 0.99856. And if you look at my score, where am I? Yeah, 205, 98672, right? So of whether you are 98672 or something else, um, the answer is no. Like nobody cares in your real life, right? So for that matter, even if I scroll down and pick something else who was probably at 500, the answer is fairly good. But your key learning that comes in from bumping up, from going up the rankings, is you learn a lot of things about how to kind of do ensembles, how to kind of not do overfitting. And I can show you another competition where I overfitted like crazy, and finally when the competition results came out, I dropped off again like crazy, right? I probably dropped in quite a few ranks itself. So again, a lot of these things are something that you won't realize it till you actually kind of learn through some of these things. So certainly Kaggle has played a very important role in my career development. The other thing is there are a lot of new techniques that you will learn that you won't find in, you won't find somebody like most of the data scientists medium articles or find something cool and work with that, right? But some of the coolest kernels and coolest ideas that I've found in my day-to-day things have come in through competition comments and other things that I have participated in. So I think a lot of these things you will learn by participating in the competition itself, and something uh, that is kind of unparalleled at the moment. So I would say, don't worry about what your rankings are, just go out and participate. The learnings that you will get out of this will be rather than saying that, oh, it's not useful on my day-to-day life. I hope I answered your question.
Yeah, I think you did. So other than this, do you have any questions? You can post it in the Q&A box there.
All right, so I think I don't have anything more. I hope you found this useful. One of the things that I will say is, like I told you earlier, I have my YouTube channel. Uh, Jethro, if I can, come join me over there. We do a lot of these sessions, hands-on sessions on ML. There are a lot of invitees itself. So, if you have a topic that you want to present, doesn't matter how easy or difficult that topic is, come over, do a presentation. We do have a lot of speakers come on. Hopefully, I'll see some of you on that YouTube channel as well. And that happens, like some panelists said earlier on, it's like, hey, I'm a coder at night, or I'm a data scientist at night, so all of these sessions happens in the evening. So yeah, feel free to come and join in as well.
I'll definitely subscribe to it. There's a new question came in, too. Two questions, right?
Two questions. All right. What's your favorite feature engineering magic sauce you in the past? um, there was this competition, so I'll tell you about that. But let me answer the next question. Based on your experience, what are the difference between a junior and a senior machine learning engineer? I would purely say experiences and being battle tested. Your junior, of course, as a junior person, you are a lot of blue-eyed, bushy-tailed, the way I would like to call it, like a squirrel. A lot of energy in there. But sometimes, it's not about whether you can do these things or not. There are a lot of other stakeholders which require management, and managing those stakeholders becomes much more important as you go senior or higher up in the organizations. And that's what, in my team, is what I look out for, right? So I do look out for, hey, can you manage, mentor other people as well? And that's what distinguishes a junior person from a senior person itself, right? If I give you a problem statement, are you going to come to me for questions, or you will figure that out and tell me, hey, and that's what would be a distinguishing feature for me from a junior versus a senior machine learning engineer. Not sure if that was what the attendee was looking for, but again, ask me any questions. What is your favorite feature engineering magic sauce that I've used? So one of the things that, again, going back to that previous uh, competition that I had, that I was showing you. So in Talking Data was extremely unbalanced. Toxic comments and Talking Data, they were extremely unbalanced itself. People came up with a lot of things of how to assign weights. Uh, some people started using, oh, let's augment the data, create more data itself. But at a point, it became so unmanageable that I remember I was sitting up at 5 a.m. in the morning, and I had access to my company GPU, which is like half a terabyte of RAM, and I was struggling to run a model on that. Right? Not everybody has access to those machines, right? So the way I had to kind of do this was I had used anomaly detection to kind of generate new features, and I kind of uh, downsampled the model using isolation forest. So the depth of the tree became my feature, and then I used those features to kind of isolate the key data points and create a pseudo data set that was representative of the original data set that I had used. So that gave me a pretty good score later on. But unfortunately, I was not able to submit a good score in the end, which was okay. My model finished at 7:03 a.m. and 7 o'clock the competition had closed. So it's okay. It was a fun exercise though. So a lot of these things are something that you will discover creative ways only in Kaggle competition. I have never used that in practice. Uh, A lot of the feature engineering tricks are something that I have taught my team internally how to use it, and those have been super successful in there. Have you shared your Kaggle solution? Yep, all my Kaggle solutions are available. Uh, I don't think I've shared my code, but my comments are there. But then again, if you're interested in any one particular thing, hit me up on LinkedIn or YouTube. Let me put up my channel again, or LinkedIn. Again, my LinkedIn is the same as my YouTube, Setu Choksi. Search me up, ask me the question. I'll be more than happy to walk you through that. I've Of late I've not participated in any competition per se. Like I said, right, my two jobs and my family takes away bulk of my time. So
All
cool.
right. Yeah.
What else? Anything else?
Yeah. So I did subscribe to your YouTube channel just now.
Thank you.
No worries.
Yeah, and if you guys come on, if you guys have ideas, you want to do a presentation, come and present, right? I would love to give you guys a platform, and don't worry about who's watching, who's judging me. If you want to become good at it, sometimes you have to say screw you, and just get it done, right? So just do it, I would say.
Yeah, that's a brilliant advice right there. All right. I think you have a new question coming in.
Meaning of using CUDA or Onyx on your team. Uh, Internally, I do. Externally, I haven't. But if you guys are interested in, let's do a session on Onyx. More than happy to kind of go into the details, uh, and work through hands-on examples during the session. So if you guys are interested, again, get 5 people. At least I want 5 people to come. Find 5 people. You can be 5 people in different sessions. That's okay. But find those 5 people, come over. We can do a session separately itself, right? So any ML topic, happy to cover it in detail, in deep dive.
Got it. Thanks a lot, Situ. All right, Situ, I will need to find out my own slide. You have another question.
Sure. Is it okay to organize it?
I
Yep. You If
think
Jetro doesn't do it, come over. Come over, we can do it.
I will discuss with my co-organizers. We'll get back to you. Stay tuned to our updates. All right.
Cool.
All right. Thank you so much, Situ. Thank you so much. Despite being super busy with your work, you still choose to actually spend more than an hour to actually share all this experience, the knowledge, and the skills, and even the code base itself to our attendees. Thank you so much.
Sure.
Although the turnout rate wasn't perfect, we had 34 members out of the 40 something at RSVP. I think it's the best conversion rate we have ever so far.
Oh,
I think
nice.
mainly due to your presence. Yeah.
No, I think it starts slow, but then you guys will also pick up. So that's okay. I mean, this is 22 is amazing. So yeah, super cool.
Thanks for your encouragement. If you don't mind, I'll need to shut out my slide.
Sure. Let me put that up as well. Give me a moment.
No worries.
Let me find Zoom.
All
While
right,
you're
thank
sharing.
you. All right, guys, thank you all for coming and attend the event. It was a brilliant talk by Setu. Thanks again, Setu. Before we actually end this webinar session, we'd love to hear about your feedback about the event. You can actually scan this QR code, which I will leave it for about 30 seconds from now, to actually access feedback forms, or you will receive a feedback form link after the webinar ends through an email. All right, again, thanks everyone for coming in, and stay tuned for updates. Please check out our meetup page at PyDataKL. In there, you can also find our Discord link as well. Join our community as we often share our knowledge, share our questions and our doubts, most at daily basis. Thank you so much. I will end the webinar session now. I wish every one of you have a good evening. See ya.